started with computing power. Obviously, when we talk about AI, many times we mention the four elements of AI. So we have spoken about data, we've spoken about algorithm, spoken about scenario, and we also spoke about what was the third one? Algorithm, scenario, data, and now we are talking about computing power. So computing power, it's basically everything that has to do with the hardware needed for AI. So because AI has a lot of computation operation happening, so basically we have a lot of mathematical calculation that are happening in order to train AI or use an AI. So that's why we need AI accelerators, which we call processors. So these processors will be used in different devices, depending if the device is a device is done for training or for inferences. Okay, so now looking at these devices or these processors, we've spoken about CPU and we spoke about GPU, right? And then we also have what you call this, all the NPUs, which is the neural processing units. So those are the units that are used when we are training our model or when we are using our model into different devices. So for example, on your phone, you have your NPU, which is the neural processing unit. All right, so with that being said, so we will understand that the CPU will help us with kind of simple work, such as logical work or simple arithmetic work. But the GPU is more advanced. The GPU is specialized for all the matrix calculation, which are happening during a training of a model. Okay, so now when we talk about this computing power, we have a common brain or a well-known brain, which is the Ascent. So we'll talk more about the Ascent processors. So the Ascent processors are basically the processors that are used for model training and model inference. So basically, the Ascent has many series. We have, for example, the Ascent 310 and the Ascent 910. So the 310 is basically used for inference. So basically, when we are using our model, really. And then we have the Ascent 310, the 910, which is used in the training process. Okay. I'm trying to select. Okay, guys, are you guys able to see my screen?
Yes, we can see the screen.
Oh, perfect. So now, as we're looking at the Ascent processors, which are AI accelerators. So these Ascent processors will have are built in a certain architecture, right? So the Ascent processor will have basically, it will have a CPU, right? Which is the system control CPU. And then it will have an AI computing engine, which we'll call the AI core, okay? There will be an AI core and an AI CPU. So the AI CPUs and AI core will be part of the processors. So basically this ASCENT processor, so it has an AI core, which is kind of the brain of the processor itself. And then it has AI CPUs. And then we have multi-layer system on chip, which will deal with all the cache and the buffers. Okay, so basically these are the architecture of the ASCENT processor. Okay, and we also have the DVPP, which is the digital vision preprocessing module, which will actually focus on more of the graphical part of the processor. So you need to understand that these chips are just built for both for training and for inference, right? So it's basically going to support all the data centers, the edge, and all the scenarios that we're going to have. So, for example, when I spoke about the CPU will be, think of the CPU as the brain, right? The brain of the chip itself. So it's basically manage the overall system. So it's going to handle all the task scheduling. So if you have task that has to happen in a certain way, right? So the task scheduling will be handled by the CPU. The CPU will also allocate all the resources. That means the type of memory that can be used. Okay, so if you look at any device, there is a limited memory that can be used at the same time. There's a number of software. So the more software you are opening, the more it's using the memory of your computer or your phone or something like that. So now we need to, when, for example, you're training a model or you've installed the model on a certain device, the CPU will allocate the resources. That means the CPU will allocate in this memory space that need to be used by the CPU. What resource can be allocated to a certain software. So that is done by the CPU, right? And then the CPU will also manage how the power is allocated as well. Okay. So when you think of the CPU, think of the brain of the chip itself that will manage the overall system, right? So now this part of the API, the API computing engine, which will, excuse me, yeah, which will have the AI core and the AI CPUs. So now, remember now, the first thing we had was the control CPU, which will control all the overall system. Now we have the AI CPUs, right? So the AI CPUs will actually be kind of, how can I call it, like a lightweight control unit, which will assist the AI core. So what is it going to assist the AI core with? It's going to help the AI core handle things like the data, the way the algorithm is being managed. So it's basically a smart helper, right? So when we look at now the AI core itself, so the AI core itself will just be specialized in matrix operation. Remember what I said in machine learning. We have a lot of matrix calculations. So what are matrix calculations? So matrix calculation are all the mathematical calculations. So the way the model works. So an example of a matrix. Okay, so when we look at a data type, we have something like this: 1, 2, 5. So this is a vector. So this vector has a certain information. So if this is a group of data, remember what we say, this can be the size of X, the size of Y, the size of Z. So this is a three-dimensional type of data. Now, when we talk about the matrix can be as bigger as 1, 2. So this is how a matrix can be represented. Okay, so now looking at this whole is a metric. So this matrix here, you can have this matrix multiplied by another matrix. Remember when we spoke about the CNN, right? When we spoke about the CNN, we spoke about the convolutional layer where we had like a kernel which will be multiplying. So think of that now. So all those calculations will be really high level calculations. So all these matrix calculations are handled by the AI core. So these metric calculations are critical for deep learning. So now, when we look at that now, we are looking at the. Sorry, guys, just to confirm, I hope you guys can see the screen that says logical architecture of Ascent's AI processes. Is that the screen you see?
Yes, it is.
Okay, perfect. All right, so now that's what the AI core is going to do. So the AI core will be specialized in tensor and matrix operations. So basically, the AI core will be very important when we're dealing with like convolutional neural network, CNN, all the matrix calculations, which we're going to find in all the neural network. Remember when we spoke about activation functions? So the operation that activation functions are doing, they are happening in the AI core. Okay, so I've mentioned how the AI CPU will help the AI code to do this operation by arranging how the data are being allocated, how the data are being managed. All right, so now the next parts of the architecture will be the multi-layer system on chip, right? Or SoC, which means system on chip, right? So this will be basically kind of a multi-level cache, which is built on the chip itself. That's why it's called system on chip architecture. So this system is built on the chip itself. Why this system matters? Because it's going to help reduce all the latencies by minimizing all the external memory access. So basically, as your system is working on a certain, let's say it's working on these calculations here, but the same system, the same chip is needed for something else. So the multi-layer system on chip is going to manage and stop any external memory access to the CPU, for example, that is doing certain operation. So this is going to help in even like reusing the same data when, for example, you're dealing with convolutional operations in CNN. So the multi-layer SoC cache or buffer would going to help that. So how does it help? It's going to help you. It kind of keep a certain memory, just like on your computer. When you log into a certain website, you have the cache or the cookies that are saved, so that next time when you go there, it still remember the page you visited. It still remember, kind of keep an history on the password you use, something like that. So this is how this will also work in CNN, not in CNN, in the AI processors. And then the harder part will be the digital vision preprocessing module, which is the DVPP. So this is just an hardware module that will help you with processing all the visual data, like all the images, the videos, right? So it's going to help you to deal with all the operations such as decoding the images. So basically, when you look at an image, you will see maybe the name of the image is image. Okay, that's the name of the image. Image.ge. What is that? GPG, right? You have your GPEG. You have your PNG. You know what I'm talking about, right? You have an image that can be a PNG. What other extension do you see with images?
Isn't it an MPG? A PNG, yeah. PNG.
Yes, PNG, so basically when you have that now, this the digital vision preprocessing is the module that will take this image here, decode it, convert this because this is kind of a coding, it keeps an information about the picture. This is why you find, for example, you have a picture which is a PNG, it has high quality, and then you convert it to GPG, it loses the quality, because this PNG comes with a certain information to keep for the picture. So now this module here will convert this image into what we call raw tensors. So it now gives kind of a vector. So it's basically, you look at your image, maybe this was your face, the image is converted into numbers like this, so that this can be used into all the calculation in machine learning. So this is done by the DVPP. Okay, so basically it's going to help you. So that's why this DVPP is very important when we're dealing with computer vision scenarios. Okay, so just to summarize there, you understand that the control CPU will control all the logical calculation happening, manage all the tasks, and then you have your AI core, which will help with all the matrix operations, dealing with all the convolutional neural networks, right? And then it will have the AI CPU, which will assist the AI core in terms of controlling how the computation flow is happening. And then you have the SoC, or cache and buffers. So this, it will help you reduce all the latency, boost the memory access speed by stopping all other operations that are requesting the same memory. And then you have the DVPP, which is just an hardware acceleration for images, videos, in terms of pre-processing all the images and videos. All right. Okay, so you need to understand that this architecture is what we call the Da Vinci architecture. So the AI computing engine, right? So remember, now we have the computing engine, which will have the AI core and the AI CPU. It's also follow a certain architecture there, which is called the Da Vinci architecture. So we're going to talk about the Da Vinci architecture, how the Da Vinci architecture goes. So now, when we look at the way this architecture is, so all these AI processors, for example, if you look at the Ascend 910, so the Ascend 910 is not built the same way, just right, Ascend 910 is not built the same way as Ascend 310. So if you're looking for an AI processor or an accelerator for inference, so you will be using this, the Ascend 310. It's built for inference, but the Ascend 910 is built for training. So now when we look at all this, there is, when we're talking about the AI core and that's dealing with all the power allocation and all those things. So for example, this Ascend 910, in terms of power, it uses about 310 watts. And then when you look at the 810, it only uses 8 watts. So the 810, you will find it in things like your smart cameras, your Internet of Things devices, you know, all those small devices for inference. And then the 810, you find it in large training models, such as what we call the ResNet. ResNet, you have it in the ResNet. ResNet. Okay, so in these training models here, then you're gonna find the Ascend 910. Okay, so so now the Da Vinci architecture is built on the AI core. So these AI core are using the Da Vinci architecture. So basically, the structure of this AI core, right? So how is the Da Vinci architecture going to work? So the Da Vinci architecture will have a unit which we're going to call a compute unit. We have a storage system and we have control unit. So this creates the Da Vinci architecture. So when you talk about the AI core itself, using the Da Vinci architecture, so we need to understand that remember that the AI core is basically the central processing unit. You understand? The AI core will have the AI CPUs there. Okay, so now when we're looking at the Da Vinci architecture, we understand that we're going to have a compute unit in that AI core. In the AI core, we're going to have a compute unit, a storage system, and a control unit. So these parts have different functionalities in this. So we have the compute unit, which will have a cube unit, a vector unit, and a scalar unit. So this part of the chip will deal with different operations depending on what operation is being requested by the AI that is being used, right? So now you need to understand that we will have this cube unit, which will deal with its own operation. The vector unit will deal with its own operation. So basically, if we're dealing with, let's say, we have vectors calculations. So we have vectors calculations. So the part of the AI processor that is going to be used will be the vector unit. If we're dealing with scalar, will be the scalar unit. If we're dealing with matrix, will be the cube unit. All right. So now, and then we have a storage unit. So the storage unit will have an on-chip storage unit, will be the storage unit of the AI core itself, which will store whatever information that needs to be stored. And then the last one will be the control unit, which is basically the brain of the AI core. So this will be actually responsible for all the operation happening in the AI core. Okay, so now let's talk about the computing unit, the compute unit, which will have a cube unit, vector unit, and scalar unit. So in the compute unit here, this unit, as I said, will perform different calculations depending on what is being required. You know, which operation we are actually doing. Okay, so we have the cube unit, which will basically focus on all the matrix operation. Guys, remember that. So a question in the exam can be when the AI is performing matrix calculations, what unit is being used in the AI core? And then you have all your answers there. You must remember, matrix-related operations are done by the cube unit. When we're dealing with vectors calculation, we're going to have a vector unit. So even if we have vector multiplied by a scalar, so guys, remember a scalar, let's say my data, a scalar will be like this, just this, okay? X equal 5, so this is a scalar. If I have X equal 1, 3, 5. So this is a vector. And if I have X, which is okay, so this will be the this will be a matrix. Okay, so before in this course, in this AI course, we used to have a math. So this is the version we're doing now is the 3.5. But if I'm not mistaken, in 2 point something, we used to do math, and we had a section when we were doing math, and in math we were actually learning all these matrix calculations, you know. But now, as technology has moved forward, there's no need for really people to really understand the math behind the AI and everything. You can understand them, but it's not that necessary. That's why, you know, in the version like 3.5 of this course, we don't do mathematics, you know. All right, so just to understand, these are how the data can be represented. So when we're dealing with matrix calculations, we have the cubic units, the cube units being used. Dealing with vectors calculation, you have the vector unit. And then if you're dealing with scalar, you have the scalar unit. So now, so basically, why is this? What operation is really happening? When we talk about, we have calculation of metrics that are happening. So which means that we can have um, an operation. When we talk about, for example, here we talk about a 16 by 16 calculation. So that means this chip can reach up to 16 by 16 matrix. 16 by 16, what does it mean? So if I have a matrix like this, uh, 4, 3, 1. So when you look at this metric, is there anyone that knows what's the size of this metric? Anyone who knows metrics that can tell me the size of this metric?
I think it's a 3 by 3.
Yes. So we have a 3 by 3. Now imagine this chip can be able to do up to 16 by 16. That means this is 3 by 3 because we have 3 columns and 3 rows. Now imagine 16 columns, 16 rows, all those computation happening. So this is what it does. So now when we have a 16 by 16, so now these chips now here will come with, when you see, for example, you have the FP16. So when you look at the capacity of this, they tell you the vector units of this chip that you are buying from somewhere is a FP16. So you understand what that FP16 means is that it can go up to 16 bits, so it can deal with 16 by 16 matrix. So that's some technical information that are very important. If you have the FP32, you understand that you can deal up to 32 bits, you understand? So, and then you can do mathematics calculation to this level. So these information are just important when you're trying to purchase some hardware there for your, what you call this, for your model. So with an FP16, obviously, it's going to be able to deal with training and inference of deep neural network. You understand? So these are just explanation of what the compute unit can bring. Okay, so the next will be the storage system. So you need to understand that the storage system or the storage unit will just correspond to the data path. So basically, when we're dealing with all this data in this computation, in these operations, so we will need the units. The storage unit will be the units that will be storing all those information during the operation. So remember when we spoke about a neural network such as the RNN, the recurrent neural network, where it needs to remember what has happened before. So if it needs to remember what has happened before, that means we need the chip. They need to be part of the chip that will be able to actually deal with memory like that. So that way you have the storage unit. So the storage unit, if you want to understand, think about it as the memory of the AI core. Okay. Any questions so far? Any questions so far? Any questions? Okay. So when you can anybody tell me, on your computer there is a chip which actually play the role of a storage unit on your computer or your phone. And when you want to buy a computer, you always ask about it. Can anybody tell me how do we call it?
RAM.
Yes, that's it. You have your RAM. You will ask someone what's the capacity of this RAM. So you have your RAM, random access memory. So your RAM, when you look in your computer, if you open your computer, you will see it's just a small, kind of a small plate like this. It looks like this, like a small plate like this. You will find some computers that are using, if you want to buy it, it has different size. You'll find maybe DDR1, DDR2, depending on what your computer takes. So basically, think of it that way. So basically, the storage unit is just the unit which is used to store information in the computer system, you know. So as part of the storage system, we can include all your RAM. We can include all your hard drives. You understand? So, and the cloud storage can also be considered to be a storage unit, depending on what you call this, what computing powers are being used there. All right. So, storage unit will be everything that is related to the memory. So it can really increase. You can have some storage units that only take 8 bytes. Okay, you have other storage units that take 1 kilobyte, 1 megabyte, and so when we're talking about in terms of data, right? In terms of data, um, data are stored in what we call one unit is called a bit, right? And then when we have 8 bits, it gives us 1 byte. Okay, so now when we talk about if I have to think of unit measurement of distance, for example, you will say 1 meter, right? We have the unit of measurement is 1 meter. So if I say 1 kilometer, how many meters is that? How many meters do I have in 1 kilometer?
1,000.
Okay, so 1 kilometer is 1,000 meters. If I say 1 kilograms, how many grams is that? How many grams is 1 kilogram? How many grams is 1 kilogram, guys?
1,000.
1,000. Now, if I say 1 kilobyte, right? When we have the memory now on our computer, 1 kilobyte, how many bytes is that?
It's 1,000 bytes.
Anybody else with a different answer? Anyone else giving us a different answer? Does everyone agree 1 kilobyte will be 1,000 bytes? Does everyone
I
agree?
think it's 125.
Now the thing is, with 1 kilobyte is not 1,000 bytes. It's 1,024. 1,024. When you take your phone, you check your phone telling you this is maybe a capacity of I don't know how many gigabytes, but now when you try to convert them in megabytes, you try to see what it's telling you in megabyte. It doesn't. So a kilo in data does not mean what you call this. It doesn't mean 1,000. So 1 kilobyte will be 1,024 bytes. So 1 megabyte will be 1,024 kilobytes. So it's in unit of 1,024. So when we talk about 1 gig just mean you have 1,024 megabytes. Okay, guys. So this is a few things that you need to realize with that. Okay. Okay. So now when we look at all these, okay. So but now you're gonna have some systems, right? Depending on the system, but the majority of the system use the bits for the calculation. This is why we got to this capacity. Why? Because they are using the binary number. So binary number, we only have 1 and 0. So once we have 1 0, maybe 1 1, so this number here we have 4, and then once we have 8 bits, that give us 1 byte. That's how these memories are calculated. But you can get some systems that use the decimal system instead of using the binary system. So for that system that use the decimal system, those computers will give you 1 megabyte equal 1,000 bytes. They will give you the normal numbers, but the majority, like 90% of computers, phones, and all those things are using the binary system. All right. So you need to note that. All right. So in terms of the data path in the storage system, it's going to record how the data are moving from one chip to another chip, depending on how the computation is happening in the neural network. Because that is very important that we understand where the data are coming from, all the metrics calculation and everything. So this is basically how the Da Vinci architecture is built. So in the AI core, we have all these system in order for us to be able to manage how the data are going to actually be handled with all these calculations. Okay, and then the last unit will be the control unit. So in this control unit, we're going to have the machine is basically in this chip here is going to basically control how all the operations are happening. So this is the control unit. Okay. So the control units will include a system control, an iCache, a scalar PSQ. So these are just part of the control unit. We have a system control which will control all the execution process task, right? And then we have an iCache, which will basically save certain information about a certain process or a certain operation that had previously happened, okay? And then, because you need to understand that in the control unit, we need to actually understand all the flows of the data within the computer. So the control units need to know exactly where is the data coming from, where it's going. So it's basically, think of it like a traffic controller of the CPU. So it controls the whole traffic there. So it's basically will help you in terms of, let's say it needs to fetch or retrieve certain instructions from the RAM, which is your random access memory, right? It gets the instruction from the RAM, whatever has been saved there, and then it has to decode that information in terms of understanding what action needs to be taken. And then from there, when it decodes that instruction, it needs to send that information to be used now. So it coordinates the whole flow of the instructions. So basically, it ensures, the control unit will ensure that the CPU runs a certain cycle, which is to fetch the instruction, decode the instruction, execute the instruction, and if it has to save certain information, it saves the information. Okay, so you need to understand that the control unit will deal with all those operations such as mathematical operations, and it's going to actually manage the flow. So it's basically as a traffic controller of the system. So that's how the control unit is going to work. So the instructions, remember what I said, it needs to fetch the instructions from the RAM, which is the memory. It's going to decode the instruction, and then it's going to see where the instructions are going to be sent. And then it's going to continue and store whatever needs to be stored as the information there. All right, guys. So tomorrow we're going to talk about the rest of the architecture of other AI processors, how they actually work. All right, guys. Is there any questions? By the way, guys, I hope you guys are going through the previous videos and already preparing, because as soon as we are done with this class, we're going to write a mock exam, like we did for the previous one. We're going to write the mock exam, and after the mock exam, for those who will pass the mock exam, we're going to write the main exam. So I will suggest that this time we